Welcome everybody. Hopefully everyone is fine. Chapter 6 is going to be the reverse of Chapter 5. In Chapter 5 we learn how to multiply polynomials together, but in Chapter 6 we're going to learn how to do just the opposite. We're going to learn how to factor polynomials, and Section 6.1 gets us started in that direction by addressing something called the greatest common factor. All right, so the first thing I think we should do to get going in section 6.1 is to look at some monomials and try to find the greatest common factor of them. Now, instead of writing the words greatest common factor, I'm going to abbreviate that as GCF. Okay. Okay, so I'm going to give us a couple of monomials to play around with. How about 3x and 12? And what we're going to do here is we're going to try to find the greatest common divisor, or the greatest common factor of both 3x and 12. Okay? Now, as far as 3 and 12 are concerned, the biggest number that divides evenly into 3 and 12, the largest number or the greatest common factor of 3 and 12 will be 3. 3 is the greatest common divisor of both 3 and 12. Now, as far as the variables are concerned, this first monomial has one factor of x, but the second monomial does not have any factors of x. And as a result, x would not be a part of our greatest common factor of both 3x and 12. Because if I put an x down here and include x in my greatest common factor, that would be saying that x divides into 12 evenly. 3x rather divides into 12 evenly, and that is just not the case. So when it comes to variables, as far as determining the greatest common factor, what we do is we always choose the least exponent. So in other words, this first monomial here, it has one factor of x, and the second monomial does not have any factors of x, or has 0 factors of x. And because of that, in our greatest common factor for both these monomials, there would be 0 factors of x appearing. So again, the greatest common factor of 3x and 12 is just 3. Let's try another one here. Suppose we have the two monomials 2x cubed and we have 18x. So what would be the greatest common factor of both these monomials here? Well, as far as the coefficients of both these monomials concerned, namely 2 and 18, we ask ourselves, what is the biggest number that we can think of that divides evenly in 2 and 18? Well, the biggest number that divides evenly in 2 and 18 would be 2. So 2 would have to be a factor included in our greatest common factor for both of these monomials. As far as the variable x is concerned, the first monomial has 3 factors of x. The second monomial only has 1 factor of x. So in our greatest common factor for both these monomials, we would have to have the least exponent factors of x between both these monomials. That is to say, we would have only 1x appearing in our GCF, our greatest common factor. Not 3, but only 1. And so, ladies and gentlemen, 2x we would say is the greatest common factor, or the greatest common divisor of both 2x cubed and 18x. Try another one. 4x squared and 6x and 14x cubed y. What would be the greatest common factor of all three of these monomials? Well, first of all, let's just look at the coefficients, 4, 6, and 14. The biggest number, or the greatest number that divides evenly into 4, 6, and 14 would be 2. So 2 must be included in our greatest common factor. As far as x is concerned, this first monomial has two factors of x, the second monomial only has one factor of x, and the third monomial has three factors of x. But remember, when it comes to variables, we always choose the least exponent. And so therefore, as far as x is concerned, the greatest common factor of x squared, x, and x to the third power is just x to the first power. Now, we cannot have a y appearing in our greatest common factor because although the third monomial has one factor of y, the other two monomials do not have any factors of y. And so there would be no y appearing in our greatest common factor of 4x squared, 6x, and 14x cubed y. All right, let's try to find the greatest common factor of these monomials. 8a cubed b to the fourth and 12a to the fourth b to the first and 20a squared b cubed. Okay, so the greatest common factor of all three of these monomials would be what? Well, first of all, what would be the greatest divisor of 8, 12, and 20? 2 is a common divisor of 8, 12, and 20 since 2 divides evenly into 8, 12, and 20, but it's not the greatest common divisor of 8, 12, and 20. We can go bigger. And the largest number that divides evenly into all three of these coefficients, 8, 12, and 20, after a little thought, would be 4. So 4 would have to be a factor appearing in our greatest common factor for all three of these monomials. How many a's would our greatest common factor need? 3 of them, 4 of them, or 2 of them? Well, again, we always, when it comes to variables and determining the greatest common factor, we choose the least exponent. So we could only have 2 factors of a occurring in our greatest common factor. How many b's would we need? 4, 1, or 3? Well, we would need the least exponent, and so we would only need one b appearing on the greatest common factor. And so, ladies and gentlemen, 4a squared b is the least common divisor or factor of 8a cubed b to the fourth, 12a to the fourth b, and 20a squared b cubed. All right, now that we warmed up in our ability to determine some greatest common factors of 2 or more monomials, we are ready to embark upon the central theme, the focal point, if you will, in this section, and that is starting to learn how to factor polynomials. All right, what does it mean to factor a quantity? Well, suppose that we just look at a number here. Suppose we look at like 24. There's many ways to write 24 in factored form. For instance, to factor 24 means to rewrite 24 as the product of 2 or more numbers. So one way we could factor 24 is to say 2 times 12. We would say 2 times 12 then is the factored form of 24. Or there's other ways. We could say 3 times 8. Or we could say 4 times 6. In either case, these to the right of the equal signs all represent factored forms of 24. Okay, now let's lay down a definition. What does it mean to factor a polynomial? Well, to factor a polynomial means to rewrite the polynomial as the product of polynomials. All right, let's just start diving in. Let's take a look. Start off with a couple of simple polynomials. Now the instructions in this chapter are not going to say simplify or solve or evaluate. The instructions will say factor. Okay, so let's try this. I'll tell you what, before we do this, just a reminder of what chapter 6 is and how it differs from chapter 5. In chapter 5, we learn how to do this. we learned how to multiply polynomials together. So in chapter 5, we went in this direction. Well, in chapter 6, ladies and gentlemen, we're going to learn how to go in the reverse direction. Given a polynomial, we're going to learn how to rewrite it in factored form. This would be chapter 6's direction. So chapter 5 and 6 are essentially inverse chapters of each other, as they are inverse operations of one another. And your ability to factor polynomials is a very, very important skill, especially if you have to go onwards and take any other math. This is a survival skill. So don't take chapter 6 lightly. It's very, very important that we become somewhat proficient in our ability to factor polynomials. Okay. All right. Well, let's just dive right in. Let's try to factor this polynomial here. The first one we'll try is 14x plus 21. Now, to factor 14x plus 21, this binomial, means that we want to try to factor out the greatest common factor out of both these terms of this binomial. And so we got to ask ourselves, what is the greatest common factor of 14x and 21? Well, the biggest number that divides evenly into 14 and 21, the largest number that we can think of, would be 7. So 7 is definitely a part of our greatest common factor of both these binomials. Notice we cannot factor an x out of both these terms. Reason being is because the second term does not have a factor of x. So therefore, the greatest common factor of 14x and 21 is just 7. And so we're going to put an equal sign, and then I'm going to put the 7 down here because that is what I am factoring out of both these terms. That is our greatest common factor. Times, now we're going to put a set of parentheses. And now we have to figure out what we leave behind after we factor the 7 out of both 14x and 21. To answer that question, ladies and gentlemen, feel free to do this. Put each of these terms over what it is you factored out and then reduce. If you factor a 7 out of 14x, you're going to leave behind just 2x. So 2x will be left behind when you factor 7 out of 14x. Plus, when you factor 7 out of 21, you're going to leave behind just 3. And we're done. We would say that this is the factored form of the binomial we started with. Notice we've taken this binomial and we've rewritten it as the product of polynomials. That's what it means to factor a polynomial. Okay. All right, let's try another one here. The more practice you give yourself and entertain, the more efficient and more experienced you're going to become. And so I strongly recommend that you try to do as many of these as possible. We will try to factor 8a plus 10, and we ask ourselves, in order to do that, what is the greatest common factor of 8a and 10? Well, what is the biggest number or the greatest number you can think of that divides into both 8 and 10? Well, after a little thought, it's not 2, although 2 does divide into 8 and 10. We can go bigger than that. We can go all the way up to 4. Well, excuse me, not 4. I sit corrected, ladies and gentlemen. It's been a long day. 2 is the greatest number that divides into both 8 and 10. All right, so yeah, 2 is a part of our greatest common factor. Notice we cannot put an a, we cannot factor an a out of both these terms because the last term does not have a factor of a. So the only greatest common factor we can factor out of both 8a and 10 would be 2. So here we go. We put the 2 down, times, and you don't have to put the times explicitly, but then you would put a set of parentheses. And then you ask yourselves, what would you leave behind inside the parentheses after you factor 2 out of both 8a and 10? Well, to help us better answer that question, place the 8a and the 10 over the 2 and ask yourself, how do these reduce? 8a divided by 2 reduces down to 4a. So you'll leave behind 4a when you factor 2 out of 8a. Plus, when you factor 2 out of 10, you're going to leave behind 5. And this would be your answer. So this we say is the factored form of 8a plus 10. You know, when you factor a polynomial, you can always check your answer by just multiplying things back out and seeing if you get back what you originally started with. For this problem above here, to check your answer, you would take 7 times 2x, convince yourself you get back to 14x, plus, and then 7 times 3. Convince yourself you get back to plus 21. To check your answer here, we would distribute the 2 inside the parentheses. 2 times 4a gives us back the 8a, plus 2 times 5 gives us back to 10. So this must be the correct factorization of this binomial. Okay, try another one here. We'll go 9x minus 12y. To factor this binomial, again, we ask ourselves, what is the greatest common factor of 9x and 12y? Let's just concentrate on the coefficients first, the numbers. What's the greatest number that divides evenly into 9 and 12? After a little thought, you'll determine that it's got to be 3. Notice you cannot factor an x out of both terms because although the first monomial has a factor of an x, the second monomial does not have a factor of x. You cannot factor a y out of both terms. Although the second monomial has a y, the first term or the first monomial does not have a y. So it appears that 3 is the only thing that you can factor out of both these terms. 3 is the greatest common factor of both these monomial terms. So we say 3 and we put an open parenthesis and we have to figure out now what we leave behind after factoring 3 out of both these terms. To do that, again, feel free to put both these terms over the 3 and ask yourself what you leave behind. 9x divided by 3 reduces down to 3x. Minus 12y divided by 3 reduces down to 4y. And again, feel free to check your answer. If you redistribute the 3 back inside the parentheses, you should get this back. And we do, so that would be the correct factorization of that binomial. So hopefully this is making sense so far here. Let's try to factor a trinomial now. Let's try to factor out 2x squared plus 6x plus 4. And so as we stare at this trinomial here, we ask ourselves, what is the greatest common factor of all 3 terms, 2x squared, 6x, and 4? After a little thought, hopefully we can realize that 2 is the greatest common factor of all 3 terms, because 2 divides into itself, divides into 6, and divides into 4, and is the greatest common divisor of all 3 of these numbers. Unfortunately, we cannot factor an x out of all 3 terms because the last term does not have a factor of x. So the only thing we can factor out of all 3 of these terms of this trinomial is just 2. So we say equals, put the 2 down, put an open parenthesis, and then we ask ourselves, what do we leave behind? When you factor 2 out of the first term, you leave behind just what? X squared. Plus, when you factor a 2 out of 6x, you leave behind just 3x. Plus, when you factor 2 out of 4, you leave behind just 2. And there, ladies and gentlemen, is the factorization of this trinomial for now. We will learn later on that this trinomial itself can be further factored down, but we're not there yet. But we're just concentrating on factoring the greatest common factor out of all terms of a polynomial right now in section 6.1. Okay. And we'll try to factor 5ab squared plus 10a squared b squared plus 15a squared b. Whoops, sorry about that. There we go. So we want to try to factor this trinomial here. And to do so, we ask ourselves, what is the greatest common factor of all 3 of these terms? Let's just concentrate on the coefficients first. What's the biggest number or the greatest number that divides into 5, 10, and 15? After some thought, it's 5. So 5 is the greatest common factor of 5, 10, and 15. Now let's look at the variables a. Notice the first monomial has 1 factor of a, the second monomial has 2 factors of a, and the third monomial has 2 factors of a. Remember, when it comes to variables, we can only factor out the least exponent. So all we can factor out of all 3 of these terms is just 1 factor of a. So a is a part of our greatest common factor. As far as the b's are concerned, this monomial has 2 factors of b, so does this one, but this one only has 1 factor of b. And being the case, we can only factor one factor of b out of all three of these terms. So as it turns out, our greatest common factor of all three of these terms is 5ab. Times, when we factor 5ab out of all three terms, what do we leave behind? Well, when you factor 5ab out of the first term of this monomial, you leave behind what? Place this over 5ab and reduce. The 5's reduced, the a's reduce out to 1's, and b squared divided by b is b to the 2 minus 1 power, or b. So all we leave behind when we factor 5ab out of the first term is just b. Plus, when you factor 5ab out of the second term of this polynomial, what do you leave behind? Well, 10 divided by 5 leaves behind a 2. When you factor a out of a squared, you leave behind just one factor of a. And when you factor b out of b squared, you leave behind just one factor of b. So 2ab is what you leave behind when you factor 5ab out of 10a squared b squared. Plus, when you factor 5ab out of the third term, what do you leave behind? Well, 15 divided by 5 reduces down to 3. A squared divided by a to the first power reduces down to just a. And b divided by itself leaves behind just factors of 1. So in other words, you don't leave any b's behind after you factor b out of the third term. You factored all the b's out. So all you leave behind when you factor 5ab out of the last term is 3a. To check your answer, if you multiply this back in, you better get back what you started with. 5ab times b would give you back 5ab squared. 5ab multiplied by 2ab would get you back 10a squared b squared. And 5ab multiplied by 3 indeed would give you back 15a squared b. This, ladies and gentlemen, is the correct factorization of this trinomial we started with over here. All right, 30x squared, xy squared rather, minus 25x squared y. How can we factor this binomial? Well, what is the greatest common factor of 30 and 25? What's the biggest number that divides evenly into 30 and 25? After a little thought, that would be 5. So you can factor a 5 out of both these terms. How many x's can you factor out of both these terms? One of them or two of them? Well, you can only factor the least exponent out, one of them. How many y's can you factor out of both these terms? Two of them or one of them? Well, we can only factor the least exponent out as far as y is concerned, so we can only factor one factor of y out of both these terms. So 5xy is the greatest common factor of both these terms. Times, what would you leave behind in doing that? Well, when you divide out 5, or factor out 5xy out of the first term, what do you leave behind? 30 divided by 5 leaves behind 6. The x is reduced down to 1. Y squared divided by y leaves behind one factor of y. Minus. When you factor 5xy out of the last term, what do you leave behind? 25 divided by 5 leaves behind 5. X squared divided by x leaves behind x to the 2 minus 1 power, or x. And you factored all the y's out of the last term, so you would not leave any factors of y left. That's your answer. This is the factorization of this binomial here. Okay, I'm going to pause here and we'll finish section 6.1 in the next video in learning how to factor out a common binomial factor and how to factor what are called four-term polynomials. So stay tuned.